Bill, you're on.
Oh, good. Very good. Thank you. All right. We have two items on the agenda. The first is going to be our challenge for March. And the challenge for March is now on your screen. It is more of a small application rather than a simple input process output challenge. In this case, we are going to emulate a change maker in a Walmart self-checkout machine. So the machine would be able to accept or have internally a specified charge. I just have a simple example here of $32.26. It will allow the user, you, to input cash in either coins or in bills, anywhere from a penny to $100, and then show the balance that was due. Then take the money that is tendered in this little example, say $40, then show the change that would be output for that in coins and in bills. And of course, sometimes you put in the coins first, sometimes you can put in the bills first, and then the machine has to tell you what's the balance due. But when you get down to a balance of zero or even, otherwise you get change for the amount you've tendered. And you still have to allow for the fact the customer might bail out. And so in that case, you return all of the money that was tendered. For a copy of this, you can email to my email address, and I'll send you the process, and it'll be distributed on the meetup site, and you'll see it in the Silicon Valley email list. So now we will go to the challenge for this week. And at Kevin's suggestion, we came up with a Valentine's Day challenge because February 14 is Valentine's Day, and we all send a little Valentine to our honey, wherever our honey might be. So do we have any people who would like to join in and participate in the challenge? And I will stop my share and go to full screen.
Yeah. Yes,
so Bob Armstrong has got one. Okay.
Well, it's the third, I guess. But
anyone else? And of course, we thank Kevin for his ingenious, superb, well, heart demonstration, including animation and a game out of the heart. Do we have any other participants in the challenge? Speak now, please.
That would be thanking Brad. I didn't do any such thing.
Oh, I'm sorry. I said Kevin, I mean Brad. Brad's heroic effort. Thank you, Brad. All right, one last call for any other participants. And so we will yield the floor to Bob Armstrong and his demonstration of heart.
Okay, let me share screen. I think, is it, oh, there's the little button in the corner. Is my screen visible now? I guess that Leon also showed a heart. So I was interested because, let me go. So this is going to go, need to show that. And this interested me because just to do it on a practical level, I wanted to use SVG graphics. And so I actually made this on my theme or whatever for my last blog on Sunday a week ago. And one of the things is back, I've not done very much with SVG graphics, but I do have, well, it was actually a couple of weeks ago, Yeah, control. I actually, a couple of years ago, I tried to go and use it. Just I wanted to plot my electric kilowatt usage, and that's what. But I pulled up that code that I'd done then, and actually, it's not one of those things. Oh, I wonder what I hit. Let me see. Yeah, my code. Why is that not liking? Oh, it's because that's it should. I don't know. In any case, this like the graphics code is in this directory, which I don't understand. One of the things is I'm executing, actually this is my oh yeah, I was hitting wrong. Yeah, this is all on the graphics that I've got, which is very, very minimal, is in this directory. And I actually just have, oh, that's that graphic. Anyway, to get onto it and back to the actual, I'm hitting Control F6 instead of Control F9, and okay, so it blows away. But I decided actually, okay, a heart, cardioid. I went and looked that up, and here's traditional notation. Cardioid's a very, very fundamental function. So, and here it is as in current COSY, fourth COSY. And actually all the work that I did is over in my work log. So I went through this here, and you can go and load my last blog and so forth, and there's the total code. But to go through it, one of the things is I really like the notion of tau, which you may have heard of, which is a whole revolution. And okay, so I've executed tau. Then I make 40 points from 0 to tau, which is 2 pi, complete revolution. I think it's brilliant, simple simplification. And here I won't go into the definition. One of the things is and I'm really looking forward to Slava Pestov potentially talking, because he's got the whole thing of genericizing functions, but I've got to go and specify things as floats and so forth. But in any case, that complicates this significantly. But in any case, this is the definition for cardioid. And I've got T0 now as I up here, stored this as T0. One of the things is you can call them, well, they're all lists. I mean, so anyway, there's cardioid, there are all the points. And I only did 40 points. And there's an example of what. And actually, I haven't made words for translate, and they just wasn't worth doing. But to do the translation, I've just got these floating. It's minus goes and shifts it leftwards, and then it's doing floating point times on each of those two. This is a list of 2 lists of the X's and the Y's or whatever. So that translates at this point. If I put a comment symbol in there, okay, now it's translated it, and then I scaled it and saved that as T1. And then one of the things is SVG graphics, which is very general. And actually, I remember I was going to, yeah, this is worth showing. This is SVG is a very general interface, HTML interface, and seems to be the main path of the future. Although I found that it does not copy in emails. In any case, where am I here? I define this SVG format function, which is very idiosyncratic and so forth, to put it in, I've got these T1, let me go and list that again. There's the X and Y coordinates. And actually I want to flip it and the reverse goes, and I'll put a comment symbol in there. That's a list of two lists, so this just flips the order of them, which is the same as exchanging the X and Y coordinates. And then this SVG format goes and converts that into the list that SVG wants. And in fact, actually, I ended up finding it was just simplest to insert that list directly, just paste it in. But one of the things is the simplest. Let me go and open up a window here to show the graphics and oh, right. This was the original back what I put together for a polyline, very basic. So this part here is sort of a header for the whole thing, and then from there's a comma or a quote at the end there, and then this half closes it off. So that's the two parts of a to put the envelope around this string of numbers to go.
Bob, can you start to bring it to a close now? We've got to finish on the schedule.
Okay. I'll just skip that because that shows in any case, this goes and puts things together so that I get, where is it over here? In any case, it's rather simple to essentially taking the code in here, and this is all online, just goes and takes the two parts of this before and after and plugs in whatever the graphics are and throws it together, and so you have a cardioid. So, okay, I'll leave it at that because it's all online. But I wanted it to be practical and sort of at the level of the higher level languages.
Great, thank you very much. And anatomically, I would comment that his cardioid is actually closer to a real life human heart than the Valentine's Day heart value. But now I will do a wrap up with probably the simplest solution that you could do. It has the logic of the plot, but it's using simple graphics. And of course, our challenge was to plot a heart shape and then use any available method. We've gone from the ultimate, and we'll go down now to the simplest, which will just be using ASCII characters. And my approach was that first I build on my matrix package, which got me a way to create the data spaces and manipulate. I used Win32 because it has the go-to XY. I then plotted half of a heart on engineer's quad rule paper, got off my coordinates, entered them into a matrix. Of course, I only had to document left half, and then I plot left half and right half. And finally, I've added a 200 millisecond display after each character, so it builds the interest, because otherwise the plot is instantaneous. The data structures are very simple. I actually have values for row and column. They are not necessary actually, but they're locked into a values so that they're good for debugging, testing, and it makes the code much more readable. The heart of the heart is going to be a matrix 38 rows by 2 columns, which just has the row and columns of the symbols. This is the loading. Notice that in this screen, we see our entire creation of the data structure is just in the word create. And then finally, this format loads the literal values into that array. The first cell is 3-9, which says there'll be a marker at row 3, column 9, and so on for the 38 rows. This is the plot. This plot's the first half. The dupe brace row 0 do sets up a do loop over that data matrix. And then we extract the first cell of the first row, the second cell of the first row, load them into row and column, and then simply recall those values, column, row, go to XY positions of cursor, and then 2pick retrieves the ASCII symbol value that we're going to plot, and emit plots it. That does the left half. This is a similar, does the right half with the addition of the 19 swap minus. That does a rotate on the vertical axis around column number 10. And then we do a little cleanup. The 200 milliseconds is a delay. And at the end, the 7 spaces 3 drop exits our structure. And here's the run, outer run loop. In this case, we clear the screen. We accept an ASCII left paren, ASCII right paren, then locate the heart database, and the plot uses those characters to plot the left and right half of the heart. I'll show it next in real time. This is a video, and I'll plot the heart twice. The first time is done with left and right parens, and the second plot is done with left and right greater than, less than signs. Notice it's more fun to watch when it's got the delays in here. Of course, the fourth doing this is instantaneous. So that's the heart of my heart. The comments and summary is that I was able to do this whole application in about 15 minutes because the hard work was all done in the matrix package, got me the data structures and the access methods. I took advantage of the object symmetry, and so I only had to manually plot the left-hand side, and the right hand took care of itself. And finally, this is a clue for our presenters, so please pay attention to this. I use Zoom to record the enlarged real-time display. In other words, ahead of this meeting, I went on to Zoom, I set up the one screen display, I went to a screen share on my own computer, and I turned on record. And so this way I was able to record that real-time display and then edit it because there was a little junk on the beginning and end. So this is a way to get a sharp, terse, clean display that really educates your viewer. When you bring up a plot on screen where you're showing your whole desktop and then try to bring out one window and make it clear, it is very difficult. So the best way is in real time, record it, edit it down, and show it. So with that, we will pass on. I thank you for your kind attention. I'm on kind of a schedule. I have to leave. The meeting can continue on, and we thank you very much for your participation. And now back to Kevin.
All right, thank you. Thank you, Bill. That was awesome. And I hope many of you will participate in next month's challenge now that you have it. It'll be posted on Meetup shortly, or you can email Bill at his address that he posted on the chat to get your copy of the detailed instructions. Bob, we're running a little short of time, so I'm just going to say if it's interested in Bob's talk at FunctionConf 2022, look at the link and description on the meetup agenda for today's meeting. And we'll skip over Bob's commercial because owing my incompetence, we haven't a lot of time for Don Golding. So Don will take the last 15 minutes of the session, and he's in charge. Brad, you're going to